Okay guys, we are on Unit 10, Day 1, so we're going to be doing this worksheet together. We're going to be covering variation functions. So we're going to take a couple notes at the beginning and then we'll work through some problems together. So let's start with those. So the first thing I'm going to give you guys is just the phrase. So we're going to say that a function varies directly. Make that an R. So you're going to get generic equations for each of these variances, so we're going to put those next. And so if it varies directly, it's just going to look like this. You're going to have y equals k times x. So if it varies directly, that means as your x is increasing, so is your y. So that would be for our direct variation. If it varies inversely, our equation would read y equals k over x. So then if our x is increasing, then our y would be decreasing. And the very last is when it varies jointly. So that means z equals k times x times y. So all three of those. So let's look at our sample problem for number 1. It says the information given states y varies directly is x. So write the direct variation function. So you look at your notes up above. If we have a direct variation function, we're going to do y equals k times x. So from here, all we're going to do is substitute in our values. So 24 equals k times 6. So we'll get our k alone. And k equals 4. So k equals 4, so that means our equation would be y equals 4x. So y equals 4x is our solution here. So we're going to kind of do another part to this. I'm going to put a little note over here on the side. So we are going to find y when x equals 2. So we're going to take this and we're going to plug it back in here. So if our x equals 2, we're going to do y equals 4 times 2. So y equals 8. So same thing for number 2. We have the same equation, or we have different variables here, but we're still varying directly. So same thing again, y equals k times x. So we'll substitute in 3 equals k times 12. So we'll divide both sides by 12. So k equals 1/4. So now we're going to take this y equals 1/4 x. And we're going to move on to part B for this one as well. So we're going to find y when x equals 2. So we'll do y equals 1/4 times 2. So y equals 1/2. So let's take a look at number 3 and number 4. So this time it says y varies inversely as x. So we have y equals 4 and x equals 5. So we will use our equation. Look back up at the top of your notes. Remember, we have it up here. It says inversely, so y equals k over x. So we'll do that back down here on 3. Y equals k over x. So for number 3, we would do 4 equals k over 5. K equals 20. So now we take that and we put it back into our equation here. So we have y equals 20 over x right there. So we'll do a part B for this one as well. So I'm going to write that over on the side here. So part B, for these two equations, we're going to find y when x equals negative 4. So we'll take our negative 4 and put that in there. So we have y equals 20 divided by negative 4. So y equals negative 5. And let's do the same thing for 4. We have y varying inversely as x. So we will do y equals k over x. So we'll plug in our values there. So we have 1/2 equals k over 6. So we end up with k equals 6. So we're going to multiply that by 1/2, so k equals 3. So once you get this, we'll plug that back in. So we have y equals 3 over x. So now we're going to do the same thing. Can you guys see that? Yeah, okay. So we'll do the same thing here. We're going to plug in our negative 4 into our equation. So we have y equals, let me switch pens so you guys can see I'm doing part B. Y equals, and then we have 3 over negative 4. So there's your final answer for that one. All right, so let's move on to the second page here. Okay. So looking at number 5, it's asking us the relationship between the values. Are they a direct variation, an inverse variation, or neither? So you'll have your notes that you can flip back and forth to, but we would suggest that you look at the pattern through your x's and the pattern through your y's. So if you look from 3 to 8, it's increasing. From 8 to 10, increasing. And from 10 to 22, it's increasing. So we're going to look at the relationship between our y's. Same thing. 15 to 40 is increasing. 40 to 50, increasing. And 50 to 110, increasing. So if you look at those three, both the x and y are increasing. So if you look back at your notes, I'll slide that back out in front. If both x and y are increasing, then our phrase would be right here. So 5 would say varies directly. So this is a direct variation. So we would write direct variation. Same thing we're looking at for 6. So 3 to 5 is up, 5 to 7, and 7 to 10.5. So that's increasing. And then look at our x's. So we have 14 down to 8.4, down to 6, and down to 4. So that's decreasing. So we have our arrow going down here. So again, you can flip back to your notes. You have x increasing and your y decreasing. That's an inverse variation. So that's the answer for 6. And 7, z varies jointly with x and y. So write the function when x equals 2, y equals 3, and z equals 60. So we're going to just take all of those variables and plug them in. So our equation from our notes says z equals k times x times y. So let's take what we know here. So we have 60 equals k times 2 times 3. So that ends up being 60 equals 6k. So we'll divide both sides by 10, or by 6, and then we get k equals 10. So k equals 10, so we would write z equals 10xy. So we can do part B again here. So this time let's do part B. We're going to find z when x equals 2 and y equals negative 3. So we're going to take our equation there. So you have z equals 10 times x times y. So we'll plug those variables in, or those values in. So we have c equals 10 times 2 times negative 3. So we end up with negative 60.